Technology is reshaping the world faster than ever, and bioinformatics and medical applications helps you make sense of it. We will focus on what it says about data and model. Stay with me, the best part is near the end. Chapter 1: Distribution and Confusion. Heat map of input attributes. Age distribution. Presence of cardiovascular disease. Cholesterol type distribution. Gender distribution. Random forest algorithm. Ensemble methods. NB confusion matrix. RF confusion matrix. DT confusion matrix. ROC curve analysis. Proposed architecture. Chapter 2: Sample and images. Framework of the experimental study of lung cancer stratification. Sample images of correctly classified and misclassified carcinoma. More sample images of correctly classified and misclassified carcinoma. Chapter 3: Network and data. Network modeling approach that simplifies multiomics data from the G. Classification of network embedding and algorithms used, 1747. Various network embedding tools and their applications, 16. Taxonomy of biological network alignment. Illustration of data and methods used in analysis of adverse drug RIA. Illustration of data and methods used in multiomics data analysis. Chapter 4: Confusion and matrix. System architecture. Localization of heart. Outcome of segmentation. Feature extraction. Ensemble classification confusion matrix, using MLP. KNN classification confusion matrix. SVM classifier confusion matrix. XGBoost classifier confusion matrix. Logistic regression classifier confusion matrix. MLP classifier confusion matrix. Random forest classifier confusion matrix. NAVE Bayes classifier confusion matrix. Chapter 5: Architecture and autoencoders. DL architecture, 2. Autoencoders, 36. Feed-forward RNN, 36. Long short-term memory, LSTM, 36. CNN architecture, 36. Framework of CNN, 36. Structure of BM, 36. DBN architecture, 36. Chapter 6: Pose and Dataset. Different poses are illustrated in the figure with the detected key P. Image illustrating different body models, 2. Challenges to human pose estimation, 7. 2D pose estimation extracted from an image and multi-person pose estimation for different num. Object annotated images from Pascal VOC dataset. These images are from KTH Multiview Football Dataset, 18. MPII Human Pose Dataset with annotated body joints. BBC Pose Dataset with overlaid sign language interpreter. COCO Dataset with the object classes. Human 3. 6M Dataset. Image correspondence with dense pose. A mass dataset. Left. Pose regression, right, pose refinement. Overview of the cascaded architecture. Results from a convolutional pose machine. Iterative error feedback, IEF, mechanism for 2D human pose estimatio. Stacked hourglass module. Architecture for HRNet. Approaching 3D human pose estimation. Left. Results from dense pose RCNN, middle, dense pose COCO dataset and dense pose RCNN model. Left, pose estimation without blanket, right, pose estimation with O. Combined CNN-RNN model. Chapter 7, Chart and Result. Estimated Healthcare IoT Device Installation, 14. System Design Flowchart. CNN Architecture. Block Diagram. Various classes of tumors. Codes used to train our CNN model. Loading page. Result displayed. Result displayed. About section. Accuracy score. Comparison chart. Chapter 8. Measurement and different. Standard level of criteria air pollutants and their sources with HE. World Regional Capital City Ranking, 2018, website, IQ Air. Diagrammatic representation of component of Hawan Samagri along with society residents chanting Vedic mantras and performing community YA. People in Indian and South Asian continent celebrating Holi festival. CCD image sensor for capturing images, website, Wikipedia. IR proximity sensor for distance measurement, website, Flipkart.com. In Yajna, besides burning material objects, chanting and praying are the IoT-based sensors capturing the humidity and temperature data FR. Measurement of different parameters of AQI on November 16, 2019, YA. Measurement of different parameters of AQI on November 17, 2019, YA. Measurement of different parameters of AQI on November 18, 2019, YA. Measurement of different parameters of AQI on November 19, 2019, YA. Comparative analysis of emission of different gaseous elements and comparative analysis of averaged environmental parameters in Fume E. Study of the comparative analysis of stability of the environment B. Collective recital of mantra helps in depression treatment and SLE. Chapter 9, Different and Hand. Benefits of Yagya or Yagiopathy, 56. Graphical analysis for fasting blood sugar with the respect to the A. Graphical presentation for FBST prandial blood sugar with the respect. Graphical representation to compare the sugar level results in 4 mon. Graphical representation to compare the FVC and FEV1 on parameters. Graphical representation to compare subject S data on different date. Radiation variation of different electronic gadgets of subjects, LAP. Left-hand analysis of happiness index of different subjects. Right-hand analysis of happiness index of different subjects. Age versus happiness index, right hand. Age versus happiness index, left hand. Chapter 10, Showing and Image. The Myo armband's usage for sign language recognition. Smart Ring Plus watch setup to detect movements of the finger during TH. The start, middle, and end frames along with the motion. Images showing annotations of various images extracted from ASL-LVDA. Image showing variation in the training and test set images. The VAR. Image showing the capturing system used in the Smile Swiss German SCI. Image showing the contents of Smile Swiss German Sign Language datas. Figure representing the recording procedure for the Signum Corpus. 1. The figure represents the 32 alphabets and the number of images opta. This some glove sensor systems among which systems. Image showing the 3D reconstruction through Kinect-based images. IM. Figure representing usage of multi-feature extraction from an image. Capsule network for the sign language recognition task, 29. Real-time sign language recognition system using pose estimation and network showing the feature extraction and the usage of LSTM to per. Difference between a sign language recognition and a sign language. Image showing the neural sign language translation by employing SEC. Image showing the different human body parts take into account and. Chapter 11. Data and Model. Yagya decreases air pollution, 60. Comparison of results. Yagyopathy experiment on diabetic patient. Final result. 1. Probabilistic optimization of machine learning algorithms for heart disease prediction. Jaspreet Kaur 1 *, Bharti Joshi 2 and Rajashri Shedge 2 1 Ramarao Adik Institute of Technology, Nerul, Navi Mumbai, India 2 Department of Computer Engineering Ramarao, Adik Institute of Technology Nerul, Navi Mumbai, India. Big data and machine learning have been effectively used in medical management, leading to cost reduction in treatment, predicting the outbreak of epidemics, avoiding preventable diseases, and improving the quality of life. Prediction begins with the machine learning patterns from several existing known datasets and then applying something very similar to an obscure dataset to check the result. In this chapter, we investigate ensemble learning, which overcomes the limitations of a single algorithm such as bias and variance by using a multitude of algorithms. The focus is not solely increasing the accuracy of weak classification algorithmic programs, however, additionally implementing the algorithm on a medical dataset wherever it is effectively used for analysis, prediction, and treatment. The consequence of the investigation indicates that ensemble techniques are powerful in improving the forecast accuracy and displaying an acceptable performance in disease prediction. Additionally, we have worked on a procedure to further improve the accuracy post-applying ensemble method by focusing on the wrongly classified records and using probabilistic optimization to select pertinent columns by increasing their weight and doing a reclassification which would result in further improved accuracy. The accuracy hence achieved by our proposed method is, by far, quite competitive. Kaggle dataset, machine learning, probabilistic optimization, decision tree, random forest, naive Bayes, k-means, ensemble method, confusion matrix, probability, Euclidean distance introduction. Healthcare and biomedicine are increasingly using big data technologies for research and development. Mammoth amount of clinical data have been generated and collected at an unparalleled scale and speed. Electronic health records, EHR, store large amounts of patient data. The quality of healthcare can be greatly improved by employing big data applications to identify trends and discover knowledge. Details generated in the hospitals fall in the following categories: clinical data, Dr. S notes, prescription data, medical imaging reports, laboratory, pharmacy, and insurance-related data. Patient data, EHRs related to patient admission details, diagnosis, and treatment. Machine-generated sensor data, data obtained from monitoring critical symptoms, emergency care data, web-based media posts, news feeds, and medical journal articles. The pharmaceutical companies, for example, can effectively utilize this data to identify new potential drug candidates, and predictive data modeling can substantially decrease the expenses on drug discovery and improve the decision-making process in healthcare. Predictive modeling helps in producing a faster and more targeted research with respect to drugs and medical devices. AI depends on calculations that can gain from information without depending on rule-based programming, while big data is the type of data that can be supplied to analytical systems so that a machine learning model could learn or, in other words, improve the accuracy of its predictions. Machine learning algorithms is classified in three sorts, particularly supervised, unsupervised, and reinforcement learning. Perhaps the most famous procedure in information mining is clustering, which is the method of identifying similar groups of data. The groups are created in a manner wherein entities in one group are more similar to each other than to those belonging to the other groups. Although it is an unsupervised machine learning technique, such collections can be used as features in supervised AI model. Coronary illness, the primary reason behind morbidness and fatality globally, was responsible for more deaths annually compared to any other cause. 1. Fortunately, cardiovascular failures are exceptionally preventable and straightforward way of life alterations alongside early treatment incredibly improves the prognosis. It is, nonetheless, hard to recognize high-risk patients because of the presence of different factors that add to the danger of coronary illness like diabetes, hypertension, and elevated cholesterol. This is where information mining and AI have acted the hero by creating screening devices. These devices are helpful on account of their predominance in pattern recognition and classification when contrasted with other conventional statistical methodologies. For exploring this with the assistance of machine learning algorithms, we gathered a dataset of vascular heart disease from Kaggle 3. It consists of 3 categories of input features, namely, objective consisting of real statistics, examination comprising of results of clinical assessment, and subjective handling patient-related information. Based on this information, we applied various machine learning algorithms and analyzed the accuracy achieved by each of the methods. For this report, we have used naive Bayes, decision tree, random forest, and various combinations of using these algorithms in order to further improve the accuracy. Numerous scientists have just utilized this dataset for their examination and delivered their individual outcomes. The target of gathering and applying methods on this dataset is to improve the precision of our model. For this reason, we gave different algorithms a shot on this dataset and successfully improved the accuracy of our model. We suggested using the ensemble method, too, which is the process of solving a particular computer intelligence problem by strategically combining multiple models, such as classifiers or experts. Additionally, we have taken the wrongly classified records by all the methods and tried to understand the reason for wrong classification and modify it mathematically in order to give accurate results and improve model performance continuously. Scope and motivation: exploring different classification and integration algorithms to perceive teams in an exceedingly real-world health record data stored electronically having high dimension capacity and find algorithms that detect clusters within reasonable computation time and ability to scale with increasing data size features while giving the highest possible accuracy. Diagnosis is a challenging process that, as of today, involves many human-to-human interactions. A machine would increase the speed of giving a diagnosis and lead to a more rapid treatment decision and would be able to detect rare events easier than humans. Literature review: over the years, many strategies have been used regarding data processing and model variability in the field of cardiovascular diagnostics. Authors in 4 show that splitting the data into 70-30 ratio using for tutoring and examination purpose and tenfold cross-proofing putting logistic regression into operation improved the accuracy of the UCI dataset to 87%. Authors in 5 have used ensemble classification techniques using multiple classifiers followed by score-level ensemble for improving the prediction accuracy. They pointed out that maximum voting produces the highest level of development. This functionality is enhanced by using feature selection. Hybrid approach has been proposed in 6 by consolidating random forest along with linear method leading to a precision of around 90%. In 7, vertical Hofting decision tree, VHDT, was used accuracy of percent using tenfold cross-validation. Authors in 8 outline a multifaceted voting system that can anticipate the conceivable presence of coronary illness in humans. It employs 4 classifiers which are SGD, KNN, random forest, and logistic regression and joins them in a consolidated way where group formation is performed by a large vote of the species making 90% accuracy. The strategy utilized in 9 finds these features by way of correlation which can help enhanced prediction results. UCI coronary illness dataset is used to evaluate the result with 6. Their proposed model accomplished precision of %, which outflanks Hofting tree technique, which reported accuracy of %. Different classifiers, mainly decision tree, NB, MLP, KNN, SCRL, RBF, and SVM have been utilized in 10. Moreover, integrated methods of bagging, boosting, and stacking have been applied to the database. The results of the examination demonstrate that the SVM strategy utilizing the boosting procedure outflanks the other previously mentioned techniques. It was exhibited in 11, after various analyses, that if we increase the feature space of RF algorithm while using forecasts and probability of a tuple to belong to a particular class from naive Bayes model, then we could increase the precision achieved in identifying the categories. By and large, studies in 12 suggested that naive Bayes gives best result when combined with random forest. Also, when KNN is combined with RF or RF plus NB, the errors remain same, suggesting that it is the dominating method. Authors in 13 compared the precision of various models in classification of coronary disease taking Kaggle dataset of 70,000 records as input. The algorithms used were random forest, naive Bayes, logistic regression, and KNN, among whom random forest was the winner with an accuracy of 73%. Creators in 14 have fused the results of the AI examination applied on different informational collections focusing on the CAD illness. Common features are compared and extracted from different datasets, and advanced concepts such as fast decision trees and pruned C4. 5 tree are administered on it, resulting in higher classification accuracy. Ensemble optimization is applied in 15, wherein fuzzy logic is used for extraction of features, genetic algorithm for reducing them, and neural network for classifying them. The results have been tested on a sample of size 30 and accuracy achieved is % based on the detailed research discussed above. We analyze by comparing different strategies suggested by different authors in their respective papers. This helps us to quickly understand where we stand presently with respect to these techniques and how they need to mature further. Comparative analysis pleased to get a comparative study of the methods and understand the strengths and weakness of each. This helped us immensely in designing our prototype. Survey analysis. Analyzing the literature, we came to know the scope and limitations of prediction techniques. In present days, heart disease rate has significantly increased and the reason behind deaths in the United States. National Heart, Lung, and Blood Institute states that cardiovascular breakdown is a problem in the typical electrical circuit of the heart and siphoning power. The incorporation of methodologies with respect to information enhancement and model variability has been coordinating preparing and testing of AI model. Cleveland dataset from the UCI file utilized a ton of time since that is a checked dataset and is generally utilized in the preparation and testing of ML models. It has 303 tuples and 14 attributes that depend on the factors that are believed to be associated with an increased risk of cardiovascular illness. Additionally, the Kaggle dataset of coronary illness containing records of 70,012 patient attributes is also used for the purpose of training and assessment. Comparative analysis of prediction techniques. Experimental testing and the use of AI indicate that supervised learning is certain calculation exceeds an alternate calculation for a particular issue or for a specific section of the input dataset. However, It is not phenomenal to discover an independent classifier that accomplishes excellent performance the domain of common problems. Ensembles of classifiers are therefore produced using many techniques such as the use of separate subset of coaching dataset in a sole coaching algorithm, utilizing distinctive coaching on a solitary coaching algorithm, or utilizing multiple coaching strategies. We learnt about the various techniques employed in ensemble method like bagging, boosting, stacking, and majority voting and their effect on the performance improvement. We also learned about Hofding tree, which is the first distributed algorithm for studying decision trees. It incorporates a novel way of dissecting decision trees with vertical parallelism. The development of effective integration methods is an effective research field in AI. Classifier ensembles are by and large more precise than the individual hidden classifiers. This is given the fact that several learning algorithms use local optimization methods that can be traced to local optima. A few methodologies find those features by relationship which can help successful predictive results. This used in combination with ensemble techniques achieves best results. Various combinations have been tried and tested and none is the standardized best approach. Each technique tries to achieve a better accuracy than the previous one and the race continues. Tools and techniques. Machine learning and information gathering utilizes ensembles on one or more learning algorithms to get different arrangement of classifiers with the ability to improve performance. Experimental studies have time and again proven that it is unusual to get one classifier which will perform the best on the general problem domain. Hence, ensemble of classifiers is often produced using any of the subsequent methods. Splitting the data and using various chunks of the training data for single machine learning algorithm. Training one learning algorithm using multiple training parameters. Using multiple learning algorithms. Key ideas such as the data setup, data classification, data mining models, and techniques are described below. Description of dataset. The source of data is Kaggle dataset for cardiovascular diseases, which contains 70,000 records with patient information. The attributes include objective information, subjective information, and results of medical examination. Enumerates the 12 attributes. A heat map is a clear representation of data where data values are represented as colors. It is used to get a clear view of the relationship between the features. The coefficient of relationship is a factual proportion of the strength of the association between the general developments of two factors with values going between and. A determined number more prominent than or less than indicates a slip-up in the relationship estimation. Represents the heat map for the input parameters of the defined dataset. Dataset attributes. Feature name variable name value type age no. Of days height centimeters weight kilograms gender categories systolic blood pressure AP_high integer diastolic blood pressure AP_low integer cholesterol 1, standard, 2, above standard, 3, well above standard. Glucose GLU1, standard, 2, above standard, 3, well above standard. Smoking smoke dual alcohol intake alco dual physical activity active dual presence or absence of CVDs cardio dual heat map of input attributes. And display the distribution of some of the input values such as age, gender, presence of cardiovascular disease, and cholesterol type. Machine learning algorithm post-analysis of the data, it was broken up into training, 80%, and testing, 20%, sets, respectively. This is necessary to accept the power of the model to summarize new details. A few classifier models have been tested which have been explained as follows. Age distribution. Presence of cardiovascular disease. Cholesterol type distribution. Gender distribution. Decision trees are amazing and well-known devices which are used for classification and forecasting. It is a tree-based classifier wherein nodes represent a test on one attribute, leaves indicate the worth of the target attribute, edge represents split of one attribute, and path is a disjunction of test to form the ultimate decision. The current implementation offers two stages of impurity, Gini impurity and entropy, and one impurity measure for regression, variability. Gini S impurity refers to the probability of a misdiagnosis of a replacement variate, if that condition is new organized randomly in accordance with the distribution of class labels from the information set. Bound by 0 occurs when data contains only one category. Gini index is defined by the formula entropy is defined as where Pj is the proportion of samples that belong to class C for a specific node. Gini impurity and entropy are used as selection criterion for decision trees. Basically, they assist us with figuring out what is a decent split point for root decision nodes on classification regression trees. Decision trees utilizes the split point to split on the feature resulting in the highest information gain, Ig, for a given criteria which is referred to as Gini or entropy. It is based on the decrease in entropy after a dataset is split on an attribute. A number of the benefits of decision tree are as follows. It requires less effort to process data while it is done in advance. It does not require standardization and data scaling. Intuitive and simple to clarify. However, it has some disadvantages too, as follows. Minor changes in the data can cause major structural changes leading to instability. Sometimes math can be very difficult in some algorithms. It usually involves more time for training. It is very expensive as the complexity and time taken is too much. Not adequate on regression and predicting continuous values. Random forest. The random forest, just as its name infers, increases the number of individual decision trees that work in conjunction. The main idea behind a random forest is the wisdom of the masses. An enormous number of moderately unrelated trees functioning as a council will surpass any existing models. Random forest allows us to change the contributions by tuning the boundaries like basis, depth of tree, and maximum and minimum leaf. It is a supervised machine learning algorithm, used for both classification and regression. It makes use of bagging and feature randomness while assembling each singular tree to try to make an uncorrelated forest whose expectation is to be more precise than that of any individual tree. The numerical clarification of the model is as given. 1. Let D be a collection of dataset used for purpose of training D equals x1, y1, xn, yn. Let W equals w1, x, w2, x, wk, x, be an ensemble of weak classifiers. If every wk is a decision tree, then the parameters of the tree are described as 4. Output of each decision tree is a classifier wk, x, equals w, xk. Hence, final classification f, x, equals majority voting of wk, x. Gives a pictorial representation of the working of random forest. Some of the advantages of random forest algorithm are as follows. Reduces overfitting problem. Solves both classification and regression problems. Handles missing values automatically. Stable and robust to outliers. Random forest algorithm. Some of the disadvantages are as follows. Complexity, longer training period. Naive Bayes algorithm. Naive Bayes is a fantastic AI calculation utilized for prediction which depends on Bayes' theorem. Bayes' theorem expresses that given a theory H and proof E, the relationship between possibility of pre-proof likelihood P, H, and the possibility of the following theoretical evidence P, H, E, Is assumption behind naive Bayes classifiers is that the estimation of a unique element is not dependent on the estimation of some different element taking the class variable into consideration. For instance, a product may be regarded as an apple if possibly it is red in color, round in shape, and around 10 centimeters wide. Naive Bayes classifier looks at all these highlights to offer independently to the chances that this product is an apple, although there is a potential relationship between shading, roundness, and dimension highlights. They are probabilistic classifiers and, subsequently, will compute the likelihood of every classification utilizing Bayes' hypothesis, and the classification with the most elevated likelihood will be the yield. Let D be the training dataset, Y be the variable for class and the attributes represented as X. Hence, according to Bayes' theorem, where so, replacing the X and applying the chain rule, we get, since the denominator remains same, removing it from the dependency. Therefore, to find the category Y with high probability, we use the following function. Some of the advantages of naive Bayes algorithm are as follows: easy to execute. Requires a limited amount of training data to measure parameters. High computational efficiency. However, there are some disadvantages too, as follows. It is thought that all aspects are independent and equally important, which is virtually impossible in real applications. The tendency to bias when increasing the number of training sets. Means algorithm K-means, an unsupervised algorithm, endeavors to iteratively segment the dataset into K pre-characterized and non-overlapping data groups with the end goal that one data point can have a place with just one bunch. It attempts to make the intragroup data as similar as could reasonably be expected while keeping the bunches as various, far, as could be expected under the circumstances. It appoints data points to a cluster with the end goal that the entirety of the squared separation between the data points and the group S centroid is at the minimum. The less variety we have inside bunches, the more homogeneous the data points are inside a similar group. Ensemble method is the process by which various models are created and consolidated in order to understand a specific computer intelligence problem. This prompts better prescient performance than could be acquired from any of the constituent learning models alone. Fundamentally, an ensemble is a supervised learning method for joining various weak learners' models to deliver a strong learner. Ensemble model works better when we group models with low correlation. Gives the various ensemble methods which are in use. Following are some of the techniques used for ensemble. Ensemble methods. Bagging or bootstrap aggregation assigns equal weights to each model in the ensemble. It trains each model of the ensemble separately using random subset of training data in order to promote variance. Random forest is a classical example of bagging technique where multiple random decision trees are combined to achieve high accuracy. Samples are generated in such a manner that the samples are different from each other and replacement is permitted. Boosting. The term boosting implies a gathering of calculations which changes a weak learner to strong learner. It is an ensemble technique for improving the model predictions of some random learning algorithm. It trains weak learners consecutively, each attempting to address its predecessor. There are three kinds of boosting in particular, namely, ADA boost that assigns more weight to the incorrectly classified data that would be passed on to the next model, gradient boosting which uses the residual errors made by previous predictor to fit the new predictor, and extreme gradient boosting which overcomes drawbacks of gradient boosting by using parallelization, distributed computing, out-of-core computing, and cache optimization. Stacking. It utilizes meta-learning calculations to discover how to join the forecasts more readily from at least two basic algorithms. A meta-model is a two-level engineering with level 0 models which are alluded to as base models and level 1 model which are alluded to as meta-model. Meta-model depends on forecasts made by basic models on out-of-sample data. The yields from the base models utilized as contribution to the meta-model might be in the form of real values in the case of regression and probability values in the case of classification. A standard method for setting up a meta-model training database is with k-fold cross-validation of basic models. Majority vote: each model makes a forecast, votes, in favor of each test occurrence, and the final output prediction is the one that gets the greater part of the votes. Suppose for a specific order issue we are given three diverse classification rules, C1, X, C2, X, C3, X. We join these rules by majority voting as proposed method experiment and analysis naive Bayes multimodal decision-making system, which is our proposed method, uses ensemble method of type majority voting using a combination of naive Bayes, decision tree, and random forest for analytics in the database of heart disease patients, and attains an accuracy that outperforms any of the individual methods. Additionally, it uses k-means along with the combination of the above methods for further increase the accuracy. The data pertains to Kaggle dataset for cardiovascular disease, which contains 12 attributes. Whether or not cardiovascular disease is present is contained in column carrying target value, which is a binary type having values 0 and 1 indicating absence or presence respectively. There are a total of 70,000 records having attributes for age, tallness, weight, gender, systolic and diastolic blood pressure, cholesterol, glucose, smoking, alcohol intake, and physical activity. Training and testing data is divided in the ratio 70:30. During training and testing, we tried various combinations to see their effect of accuracy of predictions. Also, we took data in chunks of 1,000, 5,000, 10,000, 50,000, and 70,000, respectively, and observed the change in patterns. We tried various combinations to check on the accuracy. NB, only naive Bayes algorithm is applied. DT, only decision tree algorithm is applied. RF, only random forest algorithm is applied. Serial, naive Bayes followed by random forest followed by decision tree, in increasing order of individual accuracy. Parallel, all three algorithms are applied in parallel and maximum voting is used. Prob 60 SP, if probability calculated by naive Bayes is greater than 60%, apply serial method, else apply parallel. PLS, first parallel then serial is applied for wrong classified records. Esca-means, combination of serial along with k-means. Pica-means, combination of parallel along with k-means. From this analysis, we found the pica-means method to be the most efficient. Though serial along with k-means achieves the best accuracy for training data, it is not feasible for real data where target column is not present. The reliability on any single algorithm is not possible for correctly classifying all the records, hence, we use more suitable ensemble method which utilizes the wisdom of the crowd. It uses the ensemble method of the type majority voting, which includes adding the decisions in favor of crisp class labels from different models and foreseeing the class with the most votes. Our goal is to achieve the best possible accuracy which surpasses the accuracy achieved by the individual methods. To show the confusion matrix plotted by naive Bayes, random forest, and decision tree individually as well as their ROC curve. NB confusion matrix, RF confusion matrix, DT confusion matrix, ROC curve analysis. Method: we observed that by applying ensemble method of type majority voting on the algorithm's decision tree, random forest, naive Bayes, and k-means, we could achieve an accuracy of %. To additionally improve the precision, we proposed the following algorithm. The design of the proposed method is as given in. Proposed architecture. Algorithm: probabilistic optimization. Initialization D dataset A1 naive _ Bayes _ output apply naive Bayes. D A2 decision _ tree _ output apply decision tree. D A3 random _ tree _ output apply random forest. D A4 k _ means _ output apply k-means. D winner 0 1 voting A1 A2 A3 A4 op winner _ max _ count 0 1. If op desired _ output, then probability _ calculation of each column with output 0 or 1 end for each value in CI count CI2 for k to count add the probability. Find the max column with which probability matches, number of columns selected as TWI. Weightage of selected columns I append the weightage with the input of data find mean square error with the training and find lowest, MSE, parameter. Calculate the Euclidean distance find the minimum distance using this formula. If probability of data and MSE and ED classify as 1 else classify as 0 the following block diagram explains the flow of algorithm. The working of the algorithm is explained briefly as follows. The ensemble method of the 4 algorithms, decision tree, random forest, naive Bayes, and k-means, is applied by majority voting and classification is obtained on presence or absence of cardiopathy. The wrongly classified records are stored in a separate dataset. The probability of each column with output is calculated and stored. For example, considering age, the probability of heart disease for age greater than 45 is more than otherwise. We calculate those columns for which probability is maximum. Only select these columns for further analysis. Calculate the weights of these columns using formula y equals mx plus c for linear data using multiple linear regression. For nonlinear data wherein the chances of misclassification are more complex functions such as tan, sigmoid, and ReLU are used for calculating the weights. Append the weights to the column at the time of classification. Calculate the mean square error and Euclidean distance. Finally, based on probability, mean square error and Euclidean distance, we classify the records as 1 or 0, which indicates presence-absence of heart disease. Hence, accuracy achieved is higher than using the classical ensemble method. Hence, our proposed methodology achieves a precision that not only surpasses the individual methods but also overshoots the combination method, and the precision achieved thus is quite competitive. Conclusion: an ensemble of classifiers is a collection of classification models whose singular forecasts are joined, by means of weighted or unweighted casting a ballot to dole out a classification mark to each new pattern. There is no single best method of creating successful ensemble methods and is being actively researched. Predicting heart disease has been a topic of interest for researchers for a long time. We therefore check the accuracy of the heart disease prediction using an ensemble of classifiers. For our study, we chose the best performing algorithms whose individual predictions made them classify as strong classifiers. We used a combination of decision tree, naive Bayes, random forest, and k-means algorithm. Since no single algorithm can guarantee maximum performance under all circumstances, we use the majority voting method to best classify the records. The dataset used for this purpose was Kaggle dataset for cardiovascular disease, which has 70,000 records on which we achieved an accuracy of %. However, we realized the potential of further increasing the accuracy by analyzing those records which were wrongly classified by most of the algorithms. The reason for it could be high bias, high variance, low precision, or low recall. So, we identified those columns' attributes which were causing the data to be misclassified by assigning probabilities to each tuple in the column and combining those probabilities by using conditional probability. Hence, We focused only on those columns which would result in accurate prediction by increasing the weight of those columns and feature reduction. Hence, by using the probabilistic approach, we could effectively remove the anomalies and increase the prediction accuracy. 2. Cancerous cells detection in lung organs of human body, IoT-based healthcare approach. Rohit Rastogi 1 *, D. Chaturvedi 2, Shilu Sagar 3, Niti Tandon 4, and Mukund Rastogi 5 1 Department of CSE, ABES Engineering College Ghaziabad, U, India 2 Dept. of Electrical Engineering, Dayalbar Educational Institute, Agra, India 3 Amity International Business School, Amity University, Noida, U, India 4 Vikram University, Ujjain, M, India 5 BTech CSE 3rd year, Department of CSE, ABES Engineering College Ghaziabad, U, India. Old age cancer was the cause of death. 40% of cancers are found in people over the age of 65. Lung cancer is one of these potentially deadly cancers. Young middle and old-aged patients, men who are chronic smokers or women who have never smoked are all victims of the disease. Therefore, a classification of lung cancer based on the associated risks, high risk, low risk, high risk, is required. The study was conducted using a lung cancer classification scheme by studying micrographs and classifying them into a deep neural network using machine learning, ML, framework. Tissue microscopy images are based on the risk of using deep concealed neural networks. Neural networks deep conversion. Deep neural networks are only used for classification based on primary image, for example, displayed name, and similarity. After that, scene recognition is performed on the stage. These algorithms help to recognize faces, tumors, people, road signs, plastics, and different perspective of visual information. The productivity of circular networks in image detection is one of the primary causes why the world has stirred to proficiency. Their in-depth learning is a major advance in computer vision, CV, that has important applications in car driving, robotics, drones, security, medical diagnostics, and treatment of blindness. Deep neural network, lung cancer, cell profiler, CADE server, Big Data Analytics in Healthcare. Introduction. NSCLC includes 3 types of cancer: squamous cell carcinoma, adenocarcinoma, and large cell carcinoma derived from lung tissue. Adenocarcinoma is a slow-growing cancer that first appears in the outer region of the lung. Lung cancer is more common in smokers, but the most well-known sort of lung cancer in non-smokers. Squamous cell carcinoma is more normal in the focal point of the lung and all the more generally in smokers, but large cell carcinoma can be found anywhere in the lung tissue and grows faster than adenomas and lung cancer. 20. According to Choi, H. and his team members, lung cancer risk classification models with gene expression function are very interesting. Change previous models based on individual symptomatic genes. They have revealed that the aim to develop a risk classification model was developed based on a novel level of gene expression network that was performed using multiple microarrays of lung adenocarcinoma, and gene convergence network investigation was carried out to recognize endurance networks. Genes representing these networks have been used to develop depth-based risk classification models. This model has been approved in 2 test sets. The efficiency of the model was strongly related to patient survival in the 2 sets of experiments and training. In multivariate analysis, this model was related with persistent anticipation and autonomous of other clinical and neurotic highlights. The researchers have shown that how the gene structures and expressions can be useful in early detection of the cancer, and suitable steps can be taken to cure the patients with higher probability of saving the lives. 4. Motivation of the study. The medical service industry is confronted with the test of the quick improvement of a lot of medical services data. The field of big data investigation is extending. You can leverage your healthcare system to provide valuable insights. As mentioned above, most of the data produced by this system is digitally printed and stored. The principal distinction between customary well-being analysis and big data well-being is the live programming component. In customary frameworks, the medical service industry depends on different ventures to examine big data. Many healthcare professionals rely on IT industry due to its huge impact. Their operating system is functional and capable of processing data in standard formats. Problem statements. Malignant lung tumor portrayed by sporadic development of lung tissue is known as lung cancer. Metastases can spread past the lungs to encompassing tissues and different pieces of the human body. Most cancers of the lung are called primary lung cancer, carcinoma. Small cell lung cancer, SCLC, and non-small cell lung cancer, NSCLC, are the important types of lung cancer. The most common symptoms of pesticides, including coughing blood, are fatigue, emphysema, and angina, coronary thrombosis. NSCLC accounts for approximately 81% to 86% of lung cancers. By this study, we are classifying the lung cancer cases as per their medical parameters. Authors' contributions. Mr. Rohit Rastogi was team lead and executed experiment. Dr. D.K. Chaturvedi created the design of the experiment. Ms. Shilu and Ms. Niti did experiments and Mr. Mukund did analysis, and all contributed in manuscript formation. Research manuscript organization chapter has been started with and followed by introduction, which contains short literature review, then motivation of study. After the problem statement and definition have been introduced, author's contribution and chapter organization are followed. After this, literature survey contains latest relevant papers and followed by proposed systems and experimental setup and analysis. After this, results and discussions have been presented, which is succeeded by recommendations and considerations, then future research directions, limitations of our study, and conclusions have been established. It is followed by acknowledgements and references. At last, in Annex, experimental dataset images and experimental snapshots have been given for readers. Definitions. Some important terminologies and key components are being explained here in the light of our experimental work. Computer-aided diagnosis system, CAID or CADX, CAID or computer-aided diagnosis, CADX, is a type of system software that has been shown to be very helpful to physicians in the recent microscopic interpretation of medical images. X-ray diagnostics, MRI, and ultrasound imaging technologies provide a wealth of information to help medical professionals to make comprehensive analyses and assessments in the short term. The CAD system processes the digital image to highlight the normal display or obvious areas such as possible illnesses and provide input to support a particular expert decision. 14. With the help of computers, all slide imaging algorithms and ML have potential future plans for digital pathology. So far, the program has been limited to physical safety but is now being studied for standard spots. CAD is an interdisciplinary technology with artificial intelligence, AI, computer elements with radiation and pathological imaging. A common program is tumor diagnosis. Sensors for the Internet of Things. The Internet of Things, IoT, encourages our lives by associating electronic gadgets and sensors through interior networks. IoT utilizes smart gadgets and the Internet to give inventive answers for different difficulties and issues identified with different business, public, and private enterprises around the world. IoT has become a significant part of our daily life that we can look about us. When all is said and done, IoT is an advancement that coordinates different savvy frameworks, systems, shrewd gadgets, and sensors. We also use quantum and nanotechnology in terms of memory, measurement, and unimaginable speeds. This can be seen as a prerequisite for creating an innovative business plan with security, reliability, and collaboration. 21. Here are 9 of the most popular IoT sensors. 1. Temperature. 2. Moisture. 3. Pressure. 4. Adjacent. 5. Surface. 6. Accelerometer. 7. Gyroscope. 8. Gas. 9. Infrared. 2. Wireless and wearable sensors for health informatics. IoT is a new concept that enables wearable devices to control healthcare. The IoT supports embedded technologies and is supported as a network of physical objects that connect data and sensors to communicate with the internal and external states of the object and its environment. Over the last decade, wearables have attracted the attention of many researchers and industries and have become very popular recently. 19. Remote human health and activity monitoring. Remote monitoring of healthcare allows you to stay at home instead of expensive medical centers like hospitals and nursing homes. Accordingly, it gives a proficient and practical option in contrast to clinical checking here. With a non-invasive, invisible, and visible wearable sensor, such a system is an excellent diagnostic tool for healthcare professionals to diagnose physiologic critical conditions and real-time patient activity from remote centers. In this way, it is intelligible that handheld sensors assume a significant part in such observation frameworks. These reconnaissance frameworks have pulled in the consideration of numerous specialists, business visionaries, and Goliath engineers. 11. Handheld sensor-based health monitoring systems include textile fibers, fabrics, elastic bands, or several kinds of adaptable sensors that can be straightforwardly associated to the human body. These sensors measure physiology such as electromyography, body temperature, electromy activity, arterial oxygen saturation, heart rate, blood pressure, electrocardiogram, and respiratory rate, and can measure physical symptoms. 5. Decision-making systems for sensor data management. Decisions are very basic and are widely used in economics. It relies upon the information and experience of the administrator, however increasingly more on target data. There are advanced tools available for demographical data measurement like wetland detection and real-time monitoring of mountains, rivers, and forests. 18. Until now, management has focused only on intuitive facts from checking data, for example, the overall status of water quality pointers, cases without accurate secondary analysis, and for effective management and decision-making. 22. Artificial intelligence and machine learning for health informatics. AI showed up in medical services during the 1970s. The main AI frameworks are basically information-based decision support systems, and the principal AI methods are utilized to foresee the classification standards of label sets. These first frameworks function admirably. Nevertheless, it is not commonly used in real patients. One of the reasons is that these systems are independent and have nothing to do with the patient's electronic medical records. Another reason is that the skill communicated in the information on these master frameworks shows that the created framework is not worthy here. 13. After winning several championships in focusing on artificial neural networks and improving complex learning, substance abuse became a new learning method. In May 2019, a team from Google and New York University announced that deep learning models used to analyze lung cancer could improve precision, and the investigation immediately covered numerous newspaper and magazine title texts. Health sensor data management trend-setting innovations, for example, cloud computing, wearable sensor gadgets, and big data will affect individuals' day-to-day life and have extraordinary potential in internet-based biological systems. It provides personal and shared consumption and information on the development of the health and welfare sector. These apparatuses give numerous better approaches to gather data physically and consequently. Many modern smartphones have some internal sensors such as a microphone, camera, gyroscope, accelerometer, compass, proximity sensor, GPS, and ambient light. 12. You can easily connect the new generation of wearable medical sensors to your smartphone and send the measurement results directly. This set is more effective and convenient than individual health measurement like BP, oxygen content in blood, and heart rate variability. Different sensors can be used for analysis and visualizations of the patient details with accurate and fast speed. This dramatic development enables both data management and collaboration. 12. Multimodal data fusion for healthcare. Given the proliferation of IoT techniques can be used to help the critical functions of healthcare management. In this way, traditional hospitals with large-scale interconnected sensor systems and extensive data collection technology have become the next generation of smart digital environments. From this point of view, intelligent health supports a complex ecosystem of intelligent spaces such as hospitals, ambulances, and pharmacies supported by powerful infrastructure stacks such as edge devices and sensor networks and use new business models and rules. 3. Heterogeneous data fusion and context-aware systems. A context-aware data fusion approach for health IoT. The improvement of inexpensive sensor gadgets and correspondence advancements is quickening the improvement of elegant homes and conditions. With the development of human body networks, wireless sensor networks, big data technologies, and cloud computing, the healthcare industry is growing rapidly and uses IoT. There are numerous difficulties, for example, heterogeneous data blending, text recognition, complex question preparing, unwavering quality, and exactness. From this point of view, intelligent health supports a complex ecosystem of intelligent spaces such as hospitals, ambulances, and pharmacies supported by powerful infrastructure stacks such as edge devices and sensor networks and use new business models and rules. 8. Literature review. According to Taimur Qadir and his team members, that machine-based lung cancer prediction model was developed to help undiagnosed lung nodules and assist physicians on screen. Such systems can reduce the number of node classifications, improve decision-making, and ultimately reduce the number of benign nodules that are tracked or manipulated unnecessarily. 9. This article outlines the main approaches to lung cancer prediction to date and highlights some of the relative strengths and weaknesses. They discuss some of the challenges of developing and validating such technologies, as well as clinical acceptance strategies. They review the main approaches used to classify lymph nodes and predict lung cancer from CT imaging data. In our experience, using the right training data and using a comprehensive CNN, achieving classification performance in regions with low 90s AUC points and sufficient training data. 9. According to Choi H. and NAKJ in this study, a gene correlation network, we created a risk classification model for lung adenocarcinoma. An extension of future research is the use of this method in concurrent networks of cancer progression. Advances in technology change the DL design and the way toward choosing delegate qualities to improve expectation exactness. They found that net score was related with sex, status of smoking, phase, and subatomic subtype. In summary, a high net score trend in men, smokers, and KRAS mutants was delayed and observed to be positive. 6. Finally, they expected future clinical trials designed with all-around controlled clinical and obsessive factors to help find clinical applications for their new danger grouping models. Yin Li and his team members have predicted the risk of lung adenocarcinoma, LUAD, is important in determining subsequent treatment strategies. Molecular biomarkers may improve risk classification for LUAD. 11. Yin Li et al. Analyzed the gene expression profile of LUAD patients by Atlas Cancer Genome, TCGA, and Omnibus Gene Expression, GEO, analysis. They first evaluated the prognostic relationship for each gene using 3 separate algorithms: notable function, random forest, and variable Koch regression. Next, survival-related genes were included in the lasso minimum and selection function models to create a LUAD risk prediction model. 17. They initially identified large dataset significant survival-related genes. A hybrid strategy was used to identify key genes associated with survival in large datasets. Enhancement analysis showed an association of these genes with tumor development and progression. A risk prediction model was created using the lasso method. The risk model was approved with 2 outside sets and 1 free set. Patients in the high-hazard bunch had a lower danger of repeat, RFS, and in general endurance, OS, than patients at low risk. We also created a registry that predicts LUAD patient operating systems, including models and risk stages. Hence, they conclude risk models may serve as a pragmatic and reliable predictor of LUAD and may provide new experiences into the atomic instruments of infection. 11, 16. Francisco Ajuaj described axial data from medical conditions and treatment options as a key challenge for accurate oncology. AI offers an unparalleled opportunity to enhance such predictive capabilities in laboratories and clinics. AI, including ML, which is the most well-known area of research, has been able to accurately identify tumors beyond relatively well-known detection patterns such as single-source omics and supervised classification of imaging datasets. According to him, this perspective, major developments, and challenges in this regard argue that the scope and depth of AI research should be expanded in order to achieve geological advances in accurate oncology. 1. According to Xu J. 20, in a large era of data on cancer genetics, wide availability of genetic information provided by next-generation sequencing techniques and rapid development of medical journals integrates AI approaches such as ML, detailed learning, and natural language processing to challenge big data and high-dimensional scalability, and uses this method to process clinical data to handle big data. It brings the knowledge that you have. It is bent, using the base. Open and lie down, it is really medicine. In this paper, they reviewed the current status and future guideline for using AI in cancer genomics in the field of workflow is genomic analysis for accurate cancer treatment. Existing AI solutions and their limitations in genetic testing for cancer and its diagnosis, including various contacts and interpretations, are being considered. The tools or common algorithms available for the leading NLP technologies in literature extraction are reviewed and compared to evidence-based clinical recommendations. According to him, this paper deals with data needs and algorithm transparency, the importance of preparing patients and physicians for real-time reproduction and assessment, and modern digital healthcare. They believe that AI is the main factor in the evolution of healthcare into a precise drug, but of the precedent that needs to be created to ensure safety and beneficial effects on healthcare. 20. Proposed systems based on histopathological image input. There are 2 steps. Model building. The shape of this model is based on the extraction function. Model evaluation. Form biological communication. Modeling attempts to preserve the extracted shape by extracting shape-based features with full focus on the shape of the model. The fixed size is considered a constraint, and it focuses on all other faces found to achieve that form of the constraint, making it easy to extract the entire model. Framework or architecture of the work. However, model evaluation includes some of the biological significance of the form, which requires the physician to have the precise and accurate information needed to evaluate the form. Model steps and parameters. Here, we will focus more on size-based clinical models. There are several steps like segmentation, dimension reduction, sampling, enhancement, and active contour mapping and classification of the objects which are involved that help you to design your model in a very efficient way, as per framework of the experimental study of lung cancer stratification. Discussions. Cancer has been the reason for death for a very long time. A little less than half of the cancer happens in individuals matured 70 to 85 years. The maximum death-prone cancer is lung cancer, where it threatens the all type of aged persons from adolescents to middle age to adults. Those who are addicted with drinking alcohol or smoking, or females who are non-smoking, all type of subjects were included in the list of casualties, unfortunately, from this illness. Thus, it is needed to separate lung cancer based on risk included, high risk, OK, and rising risk. This investigation depends on building up an arrangement conspire for lung cancers through examining minuscule images and ordering them utilizing Deep Convolution Neural Network, DCNN, which is an AI, ML, structure. Microscopic images of tissues will be characterized on the basis of risk involved using DCNN. Convolution neural networks are deep artificial neural networks that are utilized fundamentally for ordering images, group them by likenesses, and perform object recognition inside the scenes. They are the calculations that can recognize faces, tumors, people, road signs, and numerous different parts of the graphic information. The effectiveness of convolution networks in image recognition is one of the main reasons why the world has woken up for the productivity of deep learning. They are fueling significant progress in computer vision, CV, which has clear applications for self-driving vehicles, mechanical technology, security, clinical judgments, and medicines for the outwardly impaired. Experimental results and analysis. The term tissue characteristics covers a wide range of meanings, from qualitative assessment to various scientific measurements. In the extensive literature available, we expand the definition of terms, show the relationship between tissue features and images, identify some relevant physical parameters, and briefly describe the subject's medical history. Excerpts are provided to explain how tissue characterization and risk stratification. According to an article titled Automatic Classification of Lung Cancer from Cellular Images Using Deep Symmetric Neural Networks, we evaluated 3 types of cancer and trained for classification. However, pictures from the same sample belonged to the same group. While executing cross-validation algorithm in different sets of images, we found that, in set 1, there are 28 items and respective cross-validation score is 5,280 for adenocarcinoma. There are 42 items and cross-validation score is 5,478 for squamous cell carcinoma. For small cell carcinoma, there are 26 images and cross-validation score is 5,070. In set 2, there are 28 items and respective cross-validation score is 5,184 for adenocarcinoma. There are 37 items and cross-validation score is 5,220 for squamous cell carcinoma. For small cell carcinoma, there are 33 images and cross-validation score is 5,280. In set 2, there are 26 items and respective cross-validation score is 5,040 for adenocarcinoma. There are 46 items and cross-validation score is 5,310 for squamous cell carcinoma. For small cell carcinoma, There are 32 images and cross-validation score is 5,214. Samples of cancer data and analysis and show a sample of cancer types correctly classified using the data amplification method. The classification confusion matrix. Squamous cell carcinoma is often mistaken for adenocarcinoma. After successfully applying classification model in this dataset, we have to test the accuracy, precision, and recall of the model. So, we observed the confusion matrix whose results are as follows. Actual and predicted value of adenocarcinoma is 89% matched and only 11% items are not predicted correctly. Squamous cell carcinoma is predicted correctly 60%, which is less as compared to adenocarcinoma. Actual and predicted value of small cell carcinoma is 70% matched and only 30% items are not predicted correctly. It shows the original image classification and the wide range of image accuracy, respectively. Results obtained using magnification. The classification accuracy for adenocarcinoma, squamous cell carcinoma, and small cell cancer is %, and %, respectively, and the overall corrected rate is %. In addition, apply plugin to improve the classification. Finally, we improved our classification model and accuracy score of trained set and augmented sets are given below. Adenocarcinoma predicted 73% original images of lung cancer, whereas 89% for augmented images. We found that 45% original images are correctly classified and 60% augmented images are classified for squamous cell carcinoma. Small cell carcinoma is classified correctly 75% for original images and 70% for augmented images. Sample images of correctly classified and misclassified carcinoma. More sample images of correctly classified and misclassified carcinoma. In the three types of lung cancer, the efficiency of the unsupervised clustering was maximum in adenocarcinoma and minimum in squamous cell carcinoma. Squamous cell adenocarcinoma requires more images. DCNN helped to correctly classify 70% of lung cancer cells. Novelty's AI will not only identify and predict at-risk patients but will also be a large dataset available to hospitals and healthcare providers to identify changes in patient health and medical outcomes, as well as accurate diagnoses. There are cases that use faster and personal support. Treatment plan especially is provided in the manuscript for patients suffering with chronic diseases. AI information on infection states depends on learning calculations and doctor experienced in the treatment of patients with indications, signs, conclusions, medicines, and comparative results. Most clinical data fall into a wide range of limited categories, although they are distant and may be limited by potential sampling, but future studies on the adoption of approved standards are not required. This allows AI algorithms to learn information and enhance the creation of reinforcement learning loops. Future scope, limitations, and possible applications. The forthcoming examination is required to investigate how AI can customize treatment choices for singular patients to a clinician. The nature of data that AI gains from is likewise significant and an expected boundary to the far-reaching selection of exactness medication. The size of data needed for deep learning and the variety of strategies utilized makes it hard to obtain an away from of how precisely AI frameworks may function in genuine practice or how reproducible they might be in various clinical contexts. Forthcoming exploration openings are necessary to address social inclination in AI calculations, and sufficient advances should be taken to abstain from compounding medical care differences when utilizing AI apparatuses to save patients are famous. Tolerant security should be ensured and more noteworthy straightforwardness into algorithmic. Fairness is expected to guarantee acknowledgement of AI by suppliers and patients. IoT solutions for healthcare that collect, transmit, and visualize data in complex intelligent systems via wearable and field sensor networks can facilitate analytics, activity detection, and decision-making. AI and ML technologies play a significant role in this transition, but their implementation requires computational power. It is often only available using cloud services. In fact, with the increasing amount of data generated by sensors, the performance of ML-based cloud processing has several weaknesses for various reasons. Recommendations and consideration: AI in healthcare is ready to bring change and disrupt medical care. While not giving up marketing and profitability of drug addiction is the wisest guide, it balances AI, the need for comprehensive healthcare to plan and manage and reduce potential unexpected consequences. It is wise to take. For AI, the best solution is to start with a real healthcare issue, involving the relevant stakeholders, first-line users, patients, and their families, including artificial and non-AI options. You need to find a solution and work on it. It is implemented and extended by our 5 goals: better health, better care experience, doctor health, lower cost, and common rights. Conclusions: the nature of administration is significantly influenced by the nature of your Internet association, making it difficult to use. Healthcare providers require shorter response times to address potential health risks, especially when performance such as early detection, risk prevention, and activity diagnosis is guaranteed in real time. Because of the huge measure of individual data that should be overseen, data stockpiling and security are additionally vital when managing medical care. For all of this, choosing purely local administration, especially for mobility, is not yet practical due to limited processing and storage capabilities. 3 computational predictors of the predominant protein function: SARS-CoV-2 case Carlos Polanco 1-2*, Manlio F. Enriquez 3 and Gilberto Vargasalac N41, Department of Electromechanical Instrumentation, Instituto Nacional de Cardiologia Ignacio Ch. Vez, Mexico City, Mexico 2, Department of Mathematics, Faculty of Sciences, Universidad Nacional Autónoma de Mexico, Mexico City, Mexico 3 Clinical Research Center, Instituto Nacional de Cardiologia Ignacio Ch. Vez, Mexico City, Mexico 4 Research Center, Instituto Nacional de Cardiologia Ignacio Ch. Vez, Mexico City, Mexico. In this chapter, we describe the main molecular features of SARS-CoV-2 that cause COVID-19 disease, as well as a high-efficiency computational prediction called polarity index method. We also introduce a molecular classification of the RNA virus and DNA virus families and 2 main classifications: supervised and non-supervised algorithms of the predictions of the predominant function of proteins. Finally, some results obtained by the proposed non-supervised method are given, as well as some particularities found about the linear representation of proteins. Adenoviridae, advantages, algorithms, anellaviridae, arenaviridae, caliciviridae, computational predictions, coronaviridae family, disadvantages, DNA virus, herpesviridae, linear representation, non-supervised algorithms, papillomaviridae, parvoviridae, picornaviridae, PIM profile, polarity index method, poxviridae, putative proteins, rioviridae, rhabdoviridae, RNA virus, SARS-CoV-2, supervised algorithms. Introduction. The discipline called proteomics focuses, among other things, on the prediction of the predominant function of proteins, since this enables their construction by alteration or removal of their amino acids, either in its linear or in its 3-dimensional representation. This means some benefits for scholars of this discipline, since from these modifications, it is possible to obtain, mostly by accident, proteins with improved toxic action toward some pathogen. Of course, it does not mean that there are no proteins or peptides in nature that have the toxic action we are looking for. It is just that in most cases, it is less expensive to try to manufacture one than to find it among the many organisms in nature. The proteins expressing the SARS-CoV-2 that caused the COVID-19 pandemic have the particularity that their linear representation, their sequence, has a large number of amino acids, approximately 2,400 amino acids, AA. To give the reader an idea of the complexity and dimension of it, let us consider that some short peptides with antibacterial action have an average of 9 AA. Now, the capacity and robustness of the SARS-CoV-2 and all the regulatory processes can be dimensioned. Viruses, in general, have not simple mechanisms. They occupy some microns in length, a micron equals 1,000 of a millimeters, but they are specialized organisms with multiple properly regulated functions that are characterized, among other things, for completing themselves when they are in contact with the RNA or DNA of the host. This particularity suggests that they are not living organisms if we compare them with other living organisms whose species are known. Living organisms are born complete and do not get completed at birth. They have everything to reproduce themselves. This is not so with viruses. In any case, we can say that viruses are another type of life. The SARS-CoV-2 is a virus of the group of coronaviruses, whose particularity and strength is the possibility of reproducing in any living organism. This feature is not shared by all viruses. The Ebola virus only passes to certain species. Despite its lethality that is greater than 60%, it is less dangerous to our species because, when it kills its host, the virus dies with it and the damage is so fast that the number of deaths is small. This does not occur with SARS-CoV-2 that can spread rapidly and the infected subject does not show any symptoms, asymptomatic, for 4 or up to 7 days. That is the heart of bioinformatics and medical applications. If it helped, a quick subscribe keeps more summaries coming. So how do data and model connect? That is exactly where we started. Go back to the top and watch it click into place.